When solving equations involving algebraic expressions that include fractions, it will often be helpful to eliminate the fractions and then solve what's left. And in order to do that, we're going to multiply every term in the equation, whether it's a fraction or not, by a common denominator. Let's consider our first example. X plus 2 over 3 minus x minus 1 over 5 equals 1 over 15. One trick that I've found helps my students to avoid making mistakes later on with negative signs is if there's a subtraction of fractions in the problem, change it to addition. If you change a subtraction to addition, as we are in this case, you change the signs on top of that next fraction. So instead of x, we'll make it a negative x. Instead of minus 1, we'll make it a plus 1. Again, my reason for doing this is this will help me to make fewer negative sign mistakes later on in the problem. So now let's consider our denominators, 3, 5, and 15. A common denominator that every one of those numbers is a factor of would be 15. So what we're going to do to get rid of the fractions is multiply our common denominator of 15 by every term. 15 times x plus 2 over 3 plus 15 times negative x plus 1 over 5 equals 15 times 1 over 15. Now when we do this, the trick that makes it a little bit easier is to notice the number you're multiplying by can be divided by the number on the bottom of the fraction. For example, in the first part of the problem, we can say 15 divided by 3 is 5. And now we're left with 5 times x plus 2. And when we distribute, that gives us 5x plus 10. In the next section of the problem, 15 divided by the 5 on the bottom of the fraction gives us 3. 3 times negative x is minus 3x. 3 times 1 we have plus 3. On the right side of the equation, the 15 we're multiplying by and the 15 we're dividing by cancel each other out completely, and we're left with 1. That's the goal of this getting rid of fraction step, is to take an equation that may look a little complicated like the one we started with and turn it into a more basic algebraic equation. Here we combine like terms. 5x minus 3x is 2x. 10 plus 3 is 13. So we have 2x plus 13 equals 1. Then we subtract 13 from both sides, leaving us with 2x equals negative 12. And then finally we divide both parts by 2, and we're left with a solution of x equals negative 6. Let's take a look at our next equation. Here we have 2 plus 6 over x equals x plus 7. Here we only have one denominator, x. So we're going to get rid of the fraction by multiplying every term, whether it's a fraction or not, by that denominator. X times 2 plus x times 6 over x equals x times x plus x times 7. X times 2 is 2x. In the next part, the x we're multiplying by and the x we're dividing by cancel out, and we're left with 6. On the right side of the equation, we have x squared and plus 7x. So the equation that remains here is one with an x squared in it, which means we're probably going to try to solve by either factoring or the quadratic formula. Here, we want to get it equal to 0, and let's move everything to the side where the x squared is. We accomplish that by subtracting 2x from both sides and subtracting 6 from both sides. And this leaves us with 0 equals x squared plus 5x minus 6. Now this is an equation we can solve by factoring. We'll break it up into two binomials, each of which starts with x. To multiply to be negative 6 but add up to positive 5, we could use a plus 6 and a minus 1. To finish solving, we take each of these factors and one at a time set them equal to 0. The first one, we subtract 6 from both sides and we get a solution of x equals negative 6. The next one, we add 1 to both sides and we end up with a solution of x equals 1. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. So here we have one denominator, which is p. So we're going to multiply p times every term, whether it's a fraction or not, in order to get rid of the fractions. P times 2 over p plus p times 5 equals p times 8 over p plus p times 1. On the left side, p and p cancel out, giving us 2. The next term, p times 5, is 5p. On the right side, p and p cancel out, leaving us with 8. And then p times 1 is p. So there's several things you could do next here. What I would do is subtract p from both sides and subtract 2 from both sides. This leaves us on the left side of the equation with 4p. On the right side, it leaves us with 6. Then we divide both sides by 4, and we have p equals, and 6 over 4, if you reduce it to lowest terms, is 3 over 2.